The general manager for Gordon Self-Service Gasoline is interested in estimating the mean number of gallons of gasoline that are purchased by customers at his North York location. He would like to estimate to be within plus or minus decimal 50 gallons, and he would like to estimate to be 99% confidence level. Past studies have shown that the standard deviation for purchase amount is 4 gallons. So we are looking to estimate the mean number of gallons of gasoline knowing the margin error. So the margin error should be plus or minus decimal 50 gallons. So we are looking to calculate the sample size knowing the margin error. Based on our formula for margin error, we have that the margin error is the critical value for the desired level of confidence, z at alpha over 2, times the standard deviation of the entire population divided by square root n, where n is the sample size. So if we are looking to estimate that sample size, because n is under square root, to solve for n, we can square both left side and right side of our equation. In this case, the sample size will be critical value square times the standard deviation of the entire population square divided by margin error square. We have the standard deviation of the entire population. It's 4 gallons. And we have the margin error. It's decimal 50 gallons. But we do not have the critical value for the desired level of confidence. So if we try to build that confidence level of 99%, that means the part that is not within our confidence level, it's 1%. Due to the perfect symmetry, we have decimal 5% on the right side, and we have decimal 5% on the left side. We are looking to calculate this critical value, this cutoff point z at decimal 0.005. So to calculate this critical value, we are using the standard normal table. We know that with this table, we can read the area between z equals 0 to this z value. So this area, because the area on the right side is decimal 5%, the area between z equal to 0 and critical value will be 49.5%. So that means we are looking to calculate z corresponding to a probability of 495. If we are checking inside of our table, we do not have an exact value of decimal 4950. The closest value are decimal 4949 and decimal 4951. Ours is exactly in the middle. If we are checking the corresponding z value to an area equal to decimal 4949, we can have 2.5 and 7. The other one is 2.5 and 8. Because the area that we are interested in, it's exactly in the middle, we can calculate the critical value for a z as the average between 2 decimal 57 and 2 decimal 58. So if we calculate this critical value, z will be 2 decimal 5 575. So this is the critical value for the desired level of confidence. Right now we have everything to compute the sample size. So if we are using this formula, we have the critical value 2.575 squared times the standard deviation square, so 4 squared, divided by margin error square. If we plug in our calculator, we have a value of 424.36. Always rounded up to the higher integer. So we have 425 gallons per customers.